Okay, so before we begin this, if you're watching this on Friday, October 25th, 2019, it's Lacey's birthday, so you should wish her a happy birthday. And if you're watching it 10th period, you should wish Casper a happy birthday, because it's his birthday as well. I bet you guys thought the fact that I wasn't going to be here, that I wasn't going to mention your birthdays, but I did, because I care. Okay, so we're going to switch modes here, start talking about condensing logarithmic expressions. So essentially, if you go back through what we did, these aren't completed yet, but if you go back and you look at what we were doing before, we were taking one logarithmic expression and trying to write as many logs as we could and simplify that all the way down, or de-simplify it, if you will, all the way down. We're going to be doing the exact opposite now. All of these problems will be done eventually, but we're skipping ahead a little bit. So, when we're condensing logarithmic expressions, again, this is not a list of, it's not a procedure, right? It's a checklist of things that you should remember when you're going through, okay? So for example, we want to create as few logs as possible. So you're going to start with expressions that have 2 or more logarithms. The objective is to write them as one singular logarithm, right? Work from the inside out. You're going to see brackets, you're going to see parentheses with certain things happening inside. You'll see what we mean when we get to that, but work from the inside out. Try to eliminate all of the addition and subtraction by turning them into products and fractions. Okay, again, the exact opposite of what we were doing before. We were taking fractions, separating that into the difference of 2 logs. Well, now we're going to be taking the difference of 2 logs, writing that as 1 log with a fraction on the inside. Leave no coefficients for the logs. That means take that number and move it back into the exponential level. And then this is something also that we've talked about. Write all rational exponents as radicals. So if you look back at all of the things that we were trying to accomplish when we were expanding logs, we're doing the opposite of all of those when we're condensing, right? Okay, so let's talk about and pause at any moment here and make sure this stuff gets down in your notes. There's, again, a checklist of items you want to make sure, not necessarily in this order now. So let's start with this one. Okay, so we see here we have 2 logs. It's the sum of both of these logs, okay? But if you go back and you look at the problems that we were doing, what happened in almost all of those problems was the last thing we did is we took the exponent for each and wrote it as a coefficient. So we're working from the bottom up here when we're doing the condensing. So the numbers that are in front here, these coefficients, those are going to go back into the exponential level. So this becomes common log, right? Log base 10 of x cubed plus log base 10 of y to the 4th. So we have the sum of 2 logs. And once we have nothing here, right, nothing in front, and we have what's inside the log completely contained in there, we can combine these 2 logs by taking the product of what's inside here, right? Again, it's essentially the opposite or the reverse order of what we were doing before. Now I can put this as x cubed y to the 4th like that with the parentheses around it. You don't need these parentheses necessarily because this product is assumed to be inside that. We always want to have parentheses if we were adding or subtracting inside the log, but since it's multiplication we don't have to have them. So either that or this would be an acceptable answer for the condensing of that. Simple problem here to start.